So not too long ago, if you bought a piece of electronics, it would come with typically a big 60 hertz transformer. Not very efficient, really bad at no load. This particular one from Netgear, I don't know if it was a router or a switch. So this guy, even when it wasn't even plugged into the piece of electronics, is still going to be pulling a lot of power. And basically all this is a kind of a dumb 60 hertz low frequency transformer. This particular one, I'll come back to it, but this is from my Doorbell. Had to get rid of that. But inside this is basically going to be one of these with a bridge rectifier and a capacitor. Stepping up would be these lighter weight high frequency switchers, probably a flyback converter in here. So this may or may not be pretty efficient. You can't really tell. It's before the Energy Star regulations went into effect and the International Efficiency Mark. So there's no efficiency label on there. Then a few years back, Energy Star, California Energy Commission, I don't know, a bunch of other guys kind of drove this, but they started labeling and testing to a standard efficiency protocol and labeling supplies. So a little bit of trouble getting into focus here, but there's a Roman numeral 4 just above my thumb there. That's the there it goes. That's the efficiency mark. So a 4 means that for a power supply is under 50 watts, the no load power, which is where a lot of these guys spend their time when your device is not plugged in, your laptop's in your backpack, your cell phone's sitting in your car with one of these plugged in. So the 4 means that at no load, this is going to pull half a watt. Next generation, this is from my Dell laptop. This is actually over a 50 watt supply, but we'll test it anyway. So this has got the efficiency mark of a 5. There, coming into focus a little bit there. So this means that it is 300 milliwatts for no load power on 49 watt and less power supplies. They're moving forward with a standard for level 6. That's going to be 100 milliwatts. So let's just run through some of these. So first up, here's my 10 watt or 10 VA rather Doorbell, which basically sits unloaded all of the time. I got rid of this years ago. I'll show you what I did. This is a 10 volt amp. My doorbell light is out, so literally the only time it was ever loaded was when you push the button. So a duty cycle of 0.001% was when it was actually being used. So that sucker was pulling 1.3 watts all the time, doing nothing, just heating up my wall, with a power factor of 0.42. So then moving up, this is the one from the Netgear router, or whatever the heck it is, 1.8 watts, doing nothing. The other end is not even plugged into anything. Power factor 0.25. This switching power supply here, the cord. So this one could be good, could be bad. There's no label. I would expect in general it to be better than the low frequency Netgear. .5 watts. Where it kind of steadied out. Then the first one I have with any kind of efficiency mark is this little one, which I think was from a weather radio. This may actually still have a low frequency transfer in there. It feels pretty heavy, but it could be a toroid. So pop that in. It's supposed to be a half watt or less. Looks like it's right on the line. And then finally, my charger from my Dell laptop. This big guy here. It's basically nothing. So that covers those. I had two more supplies I wanted to get rid of in my house. First up is this one with my first alert alarm system. So it's pulling 5.9 watts right now. That is loaded. It's pretty warm actually. Power factor of 0.67. So like I said, that's loaded. That's actually running the alarm system. I think the keypad upstairs is labeled an FA260 or something like that. I don't know if that nails down the model or not. It's pretty old, but pretty popular system. So unloaded. I've just unclipped with my left hand here. It's 2 watts. Not doing anything, and that's at a power factor of 0.54. Then the last one, we upgraded our heat pump. Power went up on that just because there's a battery back in it, and or a battery backup, so it's probably topping that off a little bit right now. So our HVAC inside here was another low frequency 60 hertz transformer, 240 volt power, so I couldn't just plug it into one of those little meters, but I've got it sitting around on my lab bench. I'll show you what it's doing, and then actually I'll put it back in here and measure it loaded, but just for now, walk around. So it's this guy here. I said the Carrier Green Speed, which is like one of the most efficient heat pumps on the market, comes with this same thing. This was in my older unit as well, but it's the same 40 VA transformer. So we'll see what this does. Unloaded. Let me clip power to it. Hopefully clip up my power meter in the right direction. If not, I'll have to flip that. Sucker up. So sitting at no load, it's pulling 4.2 watts. Not doing anything. Power factor is that middle number there, the 0.1675. So like I said, this is the actual output, so definitely not loaded. This used to actually get pretty warm sitting in my system, probably not doing anything. So as the laminate heats up, it just keeps the building. I mean, it's sitting there blowing 4 watts all the time. Anyhow, I'll show you how I addressed the doorbell, the alarm system transformer, and the HVAC, and got all those numbers quite a bit lower. Have to probably pause or splice in to cover that. For the DC supplies that I covered at the beginning of the video, most electronics you buy now are going to have the better, more efficient switching supplies that come with them, and that's in part driven by Energy Star, and just it really doesn't cost any more to have that. The company I work with now, the AC to DC controllers and integrated switchers that we make, I mean, you really don't have to add any cost to get down to those, certainly the half watt no load levels, and even the 0.3 watt, and the 100 milliwatts for the level 6 is a little bit more challenging, but still certainly achievable without adding a whole lot of cost. anyhow, thanks for watching, and I'll either do a part 2 or splice the video together where I show you how I addressed this and got the power down. Thanks.